So in the preparation of alcohols, from alkenes, we have seen two methods. One is by acid catalyst hydration, and then by hydroboration oxidation we have seen. That is the first method. The second method from carbonyl compounds, we have seen again two methods by reduction of aldehydes and ketones, and then by reduction of carboxylic acids and esters. We completed these two methods. Okay, now we are going to see the third method in the preparation of alcohols. So in the preparation of alcohols, preparation of alcohols continuation. Third method from Grignard reagent. From Grignard reagent. So, if you are, we know that in the last lesson itself, we learnt about Grignard reagent and how how it was prepared. Okay, so these alcohols can be produced by the reaction of Grignard reagent with aldehydes and ketones. Okay, so first thing we have seen about mechanism for this one. Uh, Carbonyl groups. So this is carbonyl group. Okay. So when it react with Grignard reagent means R, Mg, and X. Okay. So due to that um, electroneg- uh, electronegativity. Okay, so it attains partial negative and this is a partially positive. Okay, so what will happen? So here when you are comparing carbon and oxygen is more electronegative, so it becomes like this. So it attains positive and this is a plus one. So now what will happen? No, so this R, so it will attack this carbon. Okay, attack this carbon and we will get an intermediate or attack like this. It's carbon and R is attacks this carbon and attaches with that. It's O minus. Here that Mg plus X is attaches with this oxygen. Okay, so this is an product of intermediate obtained. So when this is hydrolysis, on hydrolysis, this one we will get an alcohol. We get an alcohol means, so this is an alcohol. R and OH plus Mg OHX. So this is the mechanism involved here. Okay, so this is the mechanism involved here. So instead of R, we can give any alkyl group. Okay, so any alkyl group. So this is a general one. It's a carbonyl group we have taken. Suppose if it is an aldehyde or ketone means, so according to that, so we will get a product. Okay. For example, if we use ketone, the mechanism would be CH3, CH3, C double bond O. Okay, so this is a ketone and RMGX, RMGX. So this is a negative and this one it's a positive and this one will attack this carbon. Okay, so because of the electronegativity difference, it attains partially positive and this is a partially negative, not partially negative. So this is a negative actually. So we will get CH3, CH3, C, R will be attaches with this. Okay. Um, it's OMGX. So this is the intermediate or attack formed. So on hydrolysis of this one, it will give an alcohol, tertiary alcohol. It gives CH3, CH3, okay, R and OH. So we'll get tertiary alcohol. Okay, yeah. So this is what from Grignard reagent. So we will get an alcohol. So this is the overall reaction actually. Here the first step is nucleophilic addition of Grignard reagent to carbonyl group to form an adduct. So that means intermediate. This one, this is called it's an adduct. So this one On hydrolysis of this one, it will give an alcohol. So there are two steps involved in mechanism. Okay. So now the overall reactions, if you are using different aldehydes and different ketones, we can get the alcohol of different degree. Okay. So suppose if you are using um, methanol, methanol means one carbon. Okay. So this is methanol. Okay, so this is methanol. So when it reacts with Grignard reagent or MgX, okay, so it forms a primary alcohol. Okay, it forms a primary alcohol. So we will get an adduct CrCH2. Okay, CH2O MgX. X. On hydrolysis of this one, it produces primary alcohol, all CH2OH plus MgOHX. So this is a primary alcohol. So if you are using methanol, you will get primary alcohol. Okay. So if you are checking here, number of carbon is the difference. Okay. Here the one carbon is there, but here the number of carbon will be more. Okay. According to that, according to the need, so we can have the alkyl group. Suppose if you want to prepare ethanol, okay, so these are, it should be CH3. So according to the need, we can change this number of alkyl groups. So if you are using methanol with the Grignard reagent, you will get primary. Okay. Instead, if you are using this one, okay, uh, with R, so for differentiate, so we are putting dash here, MgX, so we will get R CH or dash OMGX. OMGX on hydrolysis. On hydrolysis, it will give secondary alcohol. Okay, so it will give secondary alcohol CH. So this is secondary alcohol. Okay, but the byproduct obtained are the same for all the reaction. Okay, yeah. So if you are using methanol, you will get a primary. So any other aldehyde, so it will give secondary. But if you are using ketone, okay, so if you are using ketone, so we will get tertiary. Already we have seen in the example itself. Okay, so R C. So to differentiate the different alkyl groups, so we put dash and double dash and all. Okay, OMGX MgX with on water on hydrolysis, it gives tertiary alcohol or dash. So this is our double dash. This is OH. This is C. Okay, so this is tertiary alcohol with MgOHX. So this is in all the three reactions. The byproduct is MgOHX. Okay, so the reaction produces primary alcohol with methanol, secondary alcohol with any other aldehyde, okay, and tertiary alcohol with ketone. Okay, so this Grignard reagent is used to differentiate primary, secondary, and tertiary alcohol. Okay, so this is from Grignard reagents we are getting alcohols. Okay, so we have till now we have seen three preparation of how we are getting alcohol from three different reactions. One more reactions I want to two more reactions I want to give, which is not given in our book, but it may be useful for you. Um, from acid chloride reduction. Okay. Acid chloride reduction. That means reducing acid chloride or acid anhydride. So we can get the alcohol. Acid chloride or acetic anhydride. Acetic anhydride reduction. So first from acid chloride. So this is an acid chloride, okay? RCOCl. So this is an acid chloride. So when it is reduced on reduction with the help of hydrogen and palladium or platinum or nickel, so we'll get primary alcohol RCH2OH. Primary alcohol we will get. Okay, so this is a primary. So in the same way, if you are using, this is acid chloride. Okay, so this is acid chloride. Then acetic anhydride, if you are using acetic anhydride or acid anhydride, so that means RC double bond O. Okay, so this is acid anhydride. R anhydride. So when it is on reduction, so here we are using lithium aluminum hydride as a reducing agent. Lithium aluminum hydride as a reducing agent. So we'll get a primary alcohol RCH2OH plus RCOOH. Even hydroxylic, even carboxylic acid also will get. Okay, so primary alcohol and acid. So this is the one reaction. So it is not in your book. And one more reaction, which is not in your book, the fermentation of carbohydrates. Everybody knows this one. Uh, I think it is given at the back side. This I think this reaction is given. Fermentation of carbohydrates. Fermentation of carbohydrates, it gives alcohol. Okay, so for carbohydrates means the formula for that is C12H, C12H22 O11. Okay, so O11 uh, on hydrolysis, so with the help of yeast, this is fermentation, no? So 300 degrees Celsius. So we will get C6H12O6, the glucose and fructose. Glucose and fructose. This is glucose and fructose. But formula of the same for both glucose and fructose. If this or if okay, this undergoes again, it decomposes. It gives C6H12O6, it gives alcohol. Okay. So why we are using water here means if you are not using water, the yeast cannot grow. Okay. Um, it cannot. So that is what we are adding water. Okay. So here the what is the enzyme you are using here? So enzyme Siamese and invertase are used to break the sugar to glucose. And actually here the what enzyme is to what this is enzyme, no? So here the enzyme used is invertase, which is used to break the sugar into glucose and fructose. Okay, so in the second reaction, so here what enzyme is used means it's a zymase. Okay, so yeast, we know that yeast has two enzymes, invertase and zymase. Yeast has two enzymes. One is invertase, so which is used in the first step. Second one zymase, which is used in the second step. Okay, so zymase, which helps in decomposes this glucose into alcohol and carbon dioxide. So this may take 2 to 3 days. In 2 to 3 days, we'll get an alcohol. So this is the fermentation of carbohydrates. Okay, yeah. So this is also one of the method by which we can prepare alcohol. Okay. Any doubt up to this alcohol preparation of alcohol is over? Any doubt? Shall we move to the preparation of phenols? Please answer. Okay. The preparation of alcohol we have seen. Next one is the preparation of phenols. Preparation of phenols. Okay. So phenols, which is also known as it's a carbolic acid, which is also known as a carbolic acid. So this is as commercially in the olden days it is prepared from coal, but now commercially it is many methods are there to prepare phenols, which is also prepared from in the lab. We are preparing these phenols from benzene derivatives. Okay, prepared from benzene derivatives. So we will see one by one. From benzene derivatives. Okay, from benzene derivatives. The first one from haloarenes. From haloarenes, we can prepare uh, alcohol, phenol. Okay, so haloarenes, which is the chlorobenzene, which is fused with NaOH at 623 Kelvin and 300. The last lesson we learned the same reaction in the chemical properties. Okay, so in the chemical here we are learning in the preparation same reaction. That is chlorobenzene. This is chlorobenzene. When it is treated with, I hope that you remember this reaction. NaOH. You remember 623 Kelvin, 300 atmospheric pressure. Then it went acid hydrolysis or anything we can HCl or H plus anything we can write. So we will get phenol. Okay, you will get phenol. So actually, you can write like this, or you can write in two steps also. Okay, the first step, so it will give um, sodium phenoxide. Actually, anything you can write. Follow the sodium phenoxide in the first step. Again, which on hydrolysis it gives phenol. Any step you can follow. If you are writing in one step, so you have to write everything here. So if you are writing in two steps, here you have to write NaOH 623 Kelvin and the 300 atmosphere, and then the second step it is HCl. Okay, yeah. Anyway you can represent the chemical equation. So first one from haloarenes. Okay, from haloarenes we are preparing this one. The second one from benzene sulfonic acid. From benzene sulfonic acid. Benzene sulfonic acid is fused with NaOH. Again, the same thing. The first step is NaOH, and second step it is acid hydrolysis. Okay. So, what is sulfonic acid? So, this is benzene sulfonic acid. SO3H. So, this is benzene sulfonic acid with NaOH. With NaOH on heating, it gives in the first step we will get again the same sodium phenoxide. This one sodium names are very important. Sodium phenoxide. Sodium phenoxide, and then with on acid hydrolysis. So this is the representation of acid hydrolysis. If you are putting H plus alone, okay, so it represents acid hydrolysis. If it is like this, it's a basic hydrolysis under base. Okay, so with the acid hydrolysis, so it will give phenol. It gives phenol. So from benzene sulfonic acid to phenol. So this is the second method for preparing phenol. Okay. Third method from diazonium salt. From diazonium salt. Diazonium salt means, you know that in the first lesson we learned about this diazonium salt. How we are getting diazonium salt means in the first lesson you learned, I think a Sandmeyer reaction from aminobenzene with nitrous acid we will get benzene diazonium salt. Okay, N2Cl, which are hydrolyzed, which are hydrolyzed by heating, so it gives phenols. By warm water or by treating with dilute acid. With warm water or with dilute acid, it produces phenol. Okay, so it produces phenol. This is the third method. So fourth method, so one more method is there from cumin. From cumin, uh, so this is the one of the method. This is a commercial method. Okay, from cumin. Okay, from cumin. So what do you mean by cumin? Cumin is a hydrocarbon, one of the hydrocarbon. So its structure is like this. So benzene, okay, benzene, and then one. So this one, so it's a secondary. Uh, this one, okay. So this is a secondary carbon which is attaches with the benzene ring. So this is cumin. This is a cumin. So when this cumin, this is isopropyl benzene. So this is isopropyl. Okay, so the structure is isopropyl. And this structure is isopropyl. Isopropyl, and this is a benzene. So it is isopropyl benzene. The common name or commercial name is its cumin. Okay, so this isopropyl benzene, which is an oxidized, when it is oxidized with oxygen in the presence of air, it produces cumin hydroperoxide. So cumin hydroperoxide. So that means the structure will be the benzene ring. It will be like this, and the carbon here it retains the same CH3, same CH3. What will happen means C O O O O H. Okay, so these two O is added with this carbon, so we'll get cumin hydroperoxide. Cumin hydroperoxide. So when you are writing the reaction, no, so you have to write the name under the compound like this. Okay, so then only when you are writing one chemical reaction, it gives all the information. Okay, substrate, reactant, what are the conditions, then product, and the name of the product. Everything, if you are giving means you no need to write give any explanation about this reaction. Okay, yeah. Instead, if you are giving all the explanation without without writing this equation properly, you won't get a full mark. Okay, so the mark is for this equation. With everything, it should be there. All the conditions and name also. So writing the name under the compound is it's very important. Okay, so this one cumin hydroperoxide, again this on acid hydrolysis, so it will give phenol. This is the commercial method. That means the commercial method means it's a profitable one. Okay, CH3CO, CH3. So this is a commercial one, and then large that is alcohol is Acetone is also obtained as a byproduct here. Okay, so this is a commercial method. So these are all the preparation of phenol. Okay, so I think no extra preparation is there for food. Yes, only wait a minute. Yes, for phenol. Okay. So any other preparation? 80 minutes. Wait. Disulfide is the phenol, which is also prepared from, I think it's a Grignard reagent. Okay, so this is not, again, it's not in our book. From Grignard reagent, it may be useful for you. Okay, from Grignard reagent. So that means it's a benzene with MgBr, okay, MgBr on oxidizing. So in the presence of light, so it will give phenol. So first thing, it's MgBrO2. So this is an adduct. Okay, so you can on hydrolysis it gives phenol. Okay, so this is one method to get phenol from Grignard reagent. Okay. Again, in the preparation of alcohol, uh, one more method is there from aniline. Okay, so aniline to diazonium. Aniline means it's a nitrobenzene to diazonium chloride with water. It gives alcohol. You know that, isn't it? Okay, I think it's over. Now will go for ether preparation. We will see later. We will go for chemical properties. Okay. Shall we move to chemical properties? Any doubt after this? We have seen the preparation of, okay, alcohol and phenol. We have seen. So the next one it is chemical properties of. First thing we are going to see chemical properties of alcohol. Okay. One by one we will see. So no, I think I forgot one thing. Sorry. Physical properties we have see. Okay, so then after that only we will see the physical chemical properties. So first we will see about its physical properties. Okay. If you are seeing the physical properties, alcohols and the phenols both are water soluble due to their ability to form H bond with water. Okay, soluble in water. Both alcohol and phenol, it's soluble in water. The reason is ability to form H bond. What do you mean by H bond? To form H bond with water. Okay, H bond means it's here the OH bond. Okay, OH, MH, and FH is a H bond. We know that. So here the ability to form H bond with water. So due to that, so alcohols and phenols are soluble in water. Actually, that solubility, that it decreases. Okay, decreases with increase in size of the uh, alkyl group, alkyl or aryl group. Okay, the solubility decreases as the increase in the size of alkyl or aryl group. Okay, Because of the same reason, the ability to form H bond with water, its boiling points are also greater than the corresponding compounds of similar molecular mass. Okay, except the carboxylic acid. Except carboxylic acid, its melting point is boiling point also higher. Boiling point also high due to H bond. Okay, so due to H bond, its boiling point is also higher. For example, the OH group in alcohols and phenols. Okay, so if you take an alcohol, so this is an alcohol, OH. This is an alcohol. Okay, so when it is combined with another alcohol, so it will be like this: with R and OH. Okay, so this one again it will react with another alcohol, intramolecular. Okay, intermolecular H bond. So this is called intermolecular H bond. So this is H bond. So these and these are, it's a H bond. Intermolecular H bond. The same reason, okay, due to this intermolecular H bond, it is easily soluble in water. Due to this intermolecular H bond, the boiling points are higher. Okay, so this is for alcohol. If you take a phenol, it's OH. Okay, this is H bond. Okay, this one it is a H bond, intermolecular H bond. Okay, yeah. So the boiling points of alcohols and phenols are higher in compared to that of other classes of compounds. For like if you are taking hydrocarbons, ethers, haloalkenes, and haloarenes of comparable molecular mass, so its boiling points are higher. The reason is intermolecular H bond. Okay. If you take ethanol and propane, so both are having almost the same molecular mass, but for ethanol, its boiling point will be higher due to this H bond. Okay. If you are taking, for example, if you are taking ethanol, so this is ethanol, CH3, CH2, um, OH, OH. So this is ethanol. Then you are taking CH3O, this is methoxy methane ether, and then if you are taking propane, CH3, CH2, CH3. So all three are comparable molecular mass. So if you take all these things, so boiling point is higher for this one. Okay, higher boiling point, higher boiling point for this alcohol, then ether, then its hydrocarbon. Okay, it's due to the presence of intermolecular H bond. Even if you are taking the solubility also for same reason we said. So if you take an alcohol, the solubility. So if you take a alcohol CH3, CH2, OH, for example, so it forms a H bond with water. Okay, H bond with water means, so this is H bond. Okay, this is H bond. So this is H bond. So due to this H bond, it has solubility. It is easily soluble in water. Okay, so but the solubility decreases with the increase in the number of alkyl groups or aryl groups. So this is all about physical properties. Only the two physical properties with reason. So all the physical properties with reason you should know. Okay, so because these are the questions which are asked in the reason and assertion and reason. Okay, so you will get the same thing. Okay, next one. So we'll see about its properties. Chemical properties of alcohols and phenols. Okay, so if you take chemical properties, alcohols are actually it's, reactive compounds. They react both as nucleophiles and electrophiles. Okay, it can be act as a nucleophiles. That means it's a negative. It can also be act as a electrophile. That is a positive. Okay, so that means the bond between OH alcohol. So this is an alcohol. No, the bond between OH is broken. This one broken when it reacts with nucleophiles. Okay, so we'll see in both the reactions. Um, suppose if you take a ROH, suppose if you take this one RCH2OH, the bond will be break here. Okay, that means CO bond cleavage. Here the CO bond cleavage. How the CO bond cleavage is taking place. So first we should know that it is ROH. O and H, we know that oxygen with the two lone pairs of electrons, when it is treated here, it is it's a nucleophiles, alcohols as nucleophiles, alcohol as nucleophiles. Because this one it's with the extra with the lone pair of electrons, even though it is a neutral, it can act as a nucleophile. Okay, so when it attacks with a carbocation, okay, attacks with carbocation, so that means it transfer its two electrons to this carbon. So we will get, okay, we'll get r o here it transfer two electron, no, so it attains positive, so it attains positive, still it has a two electron. Okay, the carbon is attached with this. Okay, so again this, if the carbon, if the oxygen has a positive means, so it is an unstable one, so it becomes R O C. So this H here, so this H will be uh, broken, and then you will get this RO plus H plus. So this is here the alcohol which acts as a nucleophile. Okay, so that means this is the first step. This is the first step. The bond between CO is broken when they react as an electron. So this is the first one. The second one, alcohol as electrophile. How it can act as a electrophile. So the bond between CO is broken. So here, so that means RCH2OH. Here nucleophile means the bond will be broken in between O and H. If it is an electrophile means the bond between CO is broken. Okay, CO means here the breaking is taking place this side. Okay, so the how the reaction will be RCH2OH plus electrophile, no? So this is an electrophile. So when it reacts with this, it's RCH2OH2. Okay. So this is, it forms first an electrophile, and this electrophile, no, when it reacts with nucleophile, it forms a compound. Okay, it forms a compound. So we will get BrCH2, okay, plus H2. So here it can alcohol which acts, it can act as a nucleophile. It can also act as a Electrophile. Okay, so that means the bond cleavage is in between O and H or in between C and O. In two way we can see the chemical properties. Okay, so the first one understood. No, this is so all are it's so they are all too quiet. No doubt for anyone. No doubt. Hmm? Any doubt? Shall I move for the next properties? I hope that I am audible. Hello, am I audible now? Am I audible? What about Niranjan? Am I audible now? Niranjan or Vaishali, Deepika, please say anything. Yes, but still, why you are not? I don't know. So if you are not giving the answer, no. So for any teacher, okay. So if you are not answering like this, it demotivates me. Okay, it's chemical properties. So the first one, the reaction involving cleavage of OH bond. Okay, reactions involving cleavage of first one, reactions involving cleavage of OH bond. Okay, so the first one, yeah, under the heading of this one, that is the cleavage of OH bond means it can be act as a nucleophile. Okay, so it is a nucleophile. So the first reaction is acidity of alcohols and phenols. Acidity of alcohols and phenols. Acidity of alcohols and phenols. So if you take this one, acidity of alcohols. First one, how do you know that alcohols and phenols are acting as a acid? So when alcohols and phenol react with metals, okay, react with metals. So what is the character of metals? So whenever it reacts, acid reacts with metal, it releases hydrogen. Okay, so from that, so we confirm that alcohols and phenols are acidic character. Okay, for example, if you take this alcohol CH3, CH2OH, ethanol, when it is treated with the sodium, so you will get sodium ethoxide, CH3, CH2ONA, sodium ethoxide with the liberation of hydrogen. Okay, so this is sodium ethoxide. Okay, so this is sodium ethoxide. So in the same way, if you take a phenol, so phenol also will react with sodium. It produces sodium phenoxide. Okay, it gives sodium phenoxide. Sodium phenoxide means this is the sodium phenoxide with the liberation of hydrogen. Okay, so these two reactions shows that alcohols and phenols are bronzed acids. So that means they can donate a proton to a stronger base. Okay, yeah. So this is the Bronsted acid. So that means donate electrons. Okay, so it can donate electrons to electrons. Okay, so that is the reaction with metals. So this is the reaction with the metals. So apart from that, in addition to this, so this one, the phenol, no? So when it is react with the sodium hydroxide, as it is an acidic character, any OH we know that it is a base. So these two or react, you will get a salt. So that is neutralization reaction. Okay. So sodium phenoxide with water. So these reactions are proof that alcohols and phenols are acidic in character. For example, if you take a base, so this is a base, okay, this is a base, and acid means we know that it's an acid. Alcohol is an acid. O, this is R, so it has two lone pair of electrons, two lone pair of electrons. Okay, so this electrons no will transfer to this hydrogen. And then this hydrogen and this oxygen hydrogen bond will be broken. Okay, so we'll get BH plus R. Already it has two electron, but still one more electron is there. So this is a base. This one is a base of the Bronsted base. That's it. Base. This is an acid. This is a conjugate acid and a conjugate base. Okay, so this is all about how, from these reactions we can confirm that alcohols and phenols are acidic in character. Okay, but how we are going to prove confirm? Okay, so this is an identified, but how we are going to prove that acidity of alcohols and phenols? First, we will see that acidity of alcohols. So if you take alcohols, the acidic character of alcohols. So we know that the acidic character alcohols are acidic. The acidic character is due to the polarity of OH bond. Okay, polar nature of OH bond. So this is actually its polarity is there, no. So due to the electronegativity difference between oxygen and hydrogen, so there will be a polarity. So the acidic character is due to the polarity of OH bond. Okay. So when an electron releasing group is added to this, okay, for example, if you take this one, this is the first, it's a primary uh, alcohol. This is also primary alcohol, no? CH2OH. This is primary. This is primary. This is also primary, and this is CH2OH. This is secondary, and this one it is tertiary. This is tertiary. So if you are taking these alcohols, okay. So we know that R, so which is a electron donating, okay, electron releasing group. So what will happen, no, so it will donate or it will release electron. So this if it release electron, the electron density and oxygen increases, no. Okay, so the release, as this alkyl group releases electrons, already because of the polarity, oxygen has a negative charge and H1 it is a positive. Okay, still increases the electron density on oxygen. So decrease the polarity of OH bond when compared to these. Okay, so if we are comparing these two primary alcohols, if you take this alcohol, okay, so here there is no alkyl groups are there. So here it is negative and this one it is a positive. So it will be easily released. If H plus is released means that has acidic character. Okay, if H plus is released in any solution, if any solution has H plus, it termed as an acidic. Okay, so if there is no alkyl group, so it will be a more acidic character. Okay, but if one alkyl group is present, as it releases electron to oxygen, it increases the electron density. Okay, so it decreases the polarity. So that means acidic character is reduced. Okay, it's reduced. So here what will happen? There are two alkyl groups are there. Still it increases the electron density over oxygen and still it reduces the acidic character. So acidic character is decreased in this order: primary, secondary and tertiary. Okay, but all are acids only. So alcohols are weaker acids than water. It's water which has an acidic character because it releases H and OH. So this is acidic character. Okay, so this is acidic. It has an acidic character, but alcohol, which is water, uh, it's an alcohol. Okay, so this is an alcohol character. Okay, so alcohols are, however, weaker acids than water. Okay, so this reaction shows that, that means what it indicates means this reaction shows that water is better proton donor than alcohol. You understood? So please, இது வந்து புரியலனா again I will teach. Understood or not? Any doubt? Why all are leaving? Am I audible? Vaishali, so you all want me to call your names. Vaishali, what about Niranjan? Any problem for anyone? Okay. So only Rayon is answering my at least my message. Thank you for that. So I don't know why others are not. I don't know whether you are all there or not. That is the doubt for me. Okay. So it's actually this water which is a better proton donor than alcohol. So this is all about acidity of alcohol. Okay. So then if you are seeing the acidity of phenols, this is very important. Acidity of phenol is very important. Acidity of phenols. The hydroxyl group of phenol is actually it's directly attached to sp2 hybridized orbital in phenols. No, so this is phenol actually. So here the OH group which is directly attaches to this sp2 carbon. Okay, sp2 hybridized carbon of benzene ring which acts as an electron withdrawing group. Okay, so this is this benzene, this system, no, so this one, so this acts as electron withdrawing group. Okay, so this acts as electron withdrawing group. So what will happen? The resonance. Okay, the resonance will happen. So you know how to do the how to write the resonance. So here it has two electrons. the electrons it's pulled by here, and so this is um, this one. So we have already seen 2 or 3 times. So this one it becomes a double bond, and O it's a plus, and H it has still one lone pair. Um, so the negative charge here. Okay, so this negative charge is here. And then what will happen? This one it's go there. So in ortho and para position, electron density it increases. Okay, so electron density it will go this side. So O plus H. Electron density will increase in ortho and para position. O plus and H. Um, okay, so this one again it goes this way. So it goes to that original. Uh, so that means due to resonance, oxygen acquires positive charge. Okay, so oxygen acquires positive charge, thus facilitate the release of H plus. Okay, yeah. So that means it's a phenol. It will be like this. It's a phenol. So actually, it's due to resonance. Due to resonance. O minus plus H plus. Okay, so due to resonance, oxygen occurs the positive charge, thus facilitate the release of H plus. Okay, phenoxide ion is also resonance stabilized. Okay, yeah. Acidity of alcohols and acidity of phenols are very important. So due to resonance, here I will write due to resonance due to resonance, oxygen acquires positive charge. This facilitate the release of H plus. Okay, so then we will get this phenoxide ion. So this is a phenoxide ion. This is phenoxide ion. Phenoxide ion is also resonance stabilized. Okay, so resonantly, the phenoxide ion is also it's a stable one. Okay, it's stable one. Due to that, the both phenol and the phenoxide ion are resonance stabilized, but the charge separation phenol is less stable than phenoxide ion. Okay, so when you are comparing these two, phenol and phenoxide ion, both are stabilized by resonance, but due to the charge separation, okay, due to the charge separation, phenol is less stable when compared to phenoxide ion. So as it is less stable, it releases H plus ion and forms phenoxide. Understood? So, okay, so due to the higher electronegativity of sp2 hybridized carbon of phenol. Okay, so the electron density decreases on oxygen. So that is what it has a positive. This increases the polarity of OH bond. Okay, so this increases the as it has a positive charge. If you are taking a polarity, so it has the more electronegative. So what it will happen? It will pull the electrons from hydrogen. Okay, if it pulls the electron from hydrogen, means what will happen? The H plus will be released. Okay, the H plus, the OH bond, the increase in the ionization of phenols. So that means it releases H plus. It releases H plus means it is a more acidic character. Okay. Okay. So we see that phenoxide, how that phenoxide ion it go with a resonance. Phenoxide. So if you take this one, so this is phenoxide. Okay, this is phenoxide. So this one it comes here, and this will go this side. So it's a resonantly, it's a stable one. Okay, it's O, and here in ortho position, again it will go this side and it will come this side. So you will get, okay, it's a double bond O. This is, or this is a resonance of phenoxide ion. Okay, it will give, it's double bond O. Again, this will go this side, and again uh, this go this side. So this is the resonance stabilization by phenoxide ion. Okay. So both phenol and phenoxide ion are resonantly stable, but due to the charge separation, so due to the polarity, the phenol is less stable than that of the phenoxide ion. So it readily releases H plus. Okay, releases H plus means it is an acidic character. Okay, so phenol is more acidic than alcohol. If you take it, more acidic than alcohol. So that means in substituted, but in substituted phenols, in the presence of electron withdrawing groups such as nitro group, which increases the acidic strength of the phenol. Okay. For example, if you take this one, OH, this is a phenol. This one, it's a phenol which is acidic. Okay, then if electron withdrawing group is present in phenol, it increases the acidity. Okay, so this is ortho position. If the electron withdrawing groups are present in ortho and meta position, so still it has acidic, more acidic, which is also, okay, which is more acidic, which one is more acidic? If the nitro groups are present on both the places of ortho places and para. So this is more acidic. Okay, this is more acidic. But at the same time, if this is electron withdrawing group, so this is electron withdrawing group, but electron releasing groups are present, what will happen? So if the electron releasing groups are present, alcohol, if it's an OH, okay, electron releasing group means it's an alkyl group. So if the alkyl groups are present, it's OH, one CH3 is present. It releases electron. Okay, so it releases electron. That means electron releasing group. So its acidity decreases. Okay, so here it's OH, one it's CH3 and CH3. So if CH3 are present on both the places of ortho and para, its acidity still decreases. Okay, electron releasing group such as alkyl group does not favor the formation of phenoxide ion. Okay, resulting in decrease of acidic strength. Presence of electron releasing group decreases the acidic strength. Okay, so this is all about its acidity of phenols. Acidity of phenols and acidity of alcohols are very, very important. Okay, so water, which is more acidic than alcohol, it's a phenol, still more acidic. the phenol with electron withdrawing group. This electron withdrawing group. So this is the order. Okay, this is the order. Order of acidic strength. So this is the order of the acidic strength. Okay. So in the book they have given pKa values. So if the pKa values are less, it has a more acidic character. So that is the meaning. Okay. So you no need to by got that, but you can compare uh, the compound which has given ortho and meta nitrophenol. Electron withdrawing groups are present, so its acidic character increases. Okay, so if there is an electron releasing groups are there, its acidic strength decreases. That alone you should be thorough. Okay,